Okay, going over the answers to some of these questions from our first scholarship session at Hillcrest High, and useful for other people as well. Question 15 from Paul Hewitt's 60 questions that physics students should know. Number 15, imagine you're standing on the surface of a shrinking planet. If it shrinks to 1/10 its original diameter with no change of mass on the shrunken surface, you would weigh how much? And let's just get a quick diagram so I can see what this looks like. This is the diameter, and it is shrinking to a smaller diameter. Excuse the noise in the background, there's a class on behind the door, a noisy class. So diameter shrinking, the concept, we don't want to jump straight to the formula, but the concept which the formula represents is that anything at a particular radius, if you double that radius, you are going to 1/4 the gravitational force. So this time though we're shrinking, so we're going to a smaller radius, so it's going to increase. So if you go to half the distance, you'll double, four times the gravitational force, and that's represented by Fg equals G m over r squared, and it's this r squared factor. The inverse part is the little trick because you're squaring, which is why you double it, it's a factor of 4, but because it's inverse, it goes to a factor of 1/4. Now if we apply that to our 1/10, so we're going to 1/10 the diameter, 1/10 squared is going to be 1/100th, but it's by a factor of inverse, by an inverse factor of 1/100th, which is inverse of 1 over 100 is the inverse of an inverse of 100, which is 100. There you go, so it's going to be 100 times as much C. Okay, next question. The fact the moon always shows its same face to Earth is evidence that the moon rotates about its axis about once per... Okay, I'm going to straight up tell you the answer is a month, it's not once per day. The Earth, here we go, rotates on its axis once per day, but we have the moon orbiting around the Earth, and we know it takes 1 month to do this. That's how a month is defined. A lunar month is a very approximate average of the calendar month. For the moon to always show the same face to the Earth, it has to rotate once around every complete circuit, every complete orbit. So that's why it's only 1 month, it takes 1 month to orbit. Okay, moving on. 17. The moon is responsible for the Earth's tides. That's actually misinformation if you've read this in advance. Which pulls more strongly on the Earth and its oceans, the moon, the sun, or both? The answer you'd think is the moon, that's your instinct, but it's not the moon, it's the sun. And the reason why is you have to think, does the Earth orbit predominantly around the sun or the moon? Okay, the Earth orbits around the sun, which is evidence of a very, very strong gravitational attraction. The moon orbits around the Earth in this frame of reference, which shows you that the force on the Earth from the moon is much less than the force on the Earth from the sun. Okay, you could plug both the Earth-Moon system and the Earth-Sun system into your gravitational formula and see which came up with the highest force, and it should be the sun. Okay, and that would indicate that the mass of the sun is so much greater in proportion to the radius squared factor, which is much larger than for the moon. Okay, moving on. 18. A spacecraft is on its way from Earth to the moon. It's pulled equally by Earth and moon when it is where? Close to the Earth surface, close to the moon surface, halfway. We know it can't be halfway because there's a squared factor in that radius, that distance between them. It's going to be either A or B. And let's just have a look at this. We've got the Earth, we've got the moon. The Earth provides a stronger force than the moon. So if you're on the surface of each, so to have an equal pull, you would have to be closer to the moon. Okay, for that smaller force to not be diminished as much by that radial distance, and that radial distance is going to diminish that force that you would experience if you're on the surface of the Earth, and until you get to that point in the middle where it is roughly equal. Okay, last one, 19. Earth satellites such as Space Shuttle orbit at altitudes that are above the Earth's atmosphere. Well, yes, it is. Gravitational field, question mark, and both of these will relate to that. The answer, well, yeah, no, I don't like going straight to the answer, but I will. The answer is gravitational, just atmosphere, not gravitational field. The gravitational field has that drop-off of 1 over r squared, but that means it'll follow a parabolic drop-off, if you can think in terms of that or visualize that, as you go further away from the Earth. Okay, that doesn't stop when you get out of the atmosphere. So another way to look at it is, for something to be in orbit around the Earth, like the space station, there's a centripetal force that's required, and that centripetal force comes from the force due to gravity. It's less than it would be if you're on the surface of the Earth, but it's still there.